So, the 6 trig functions can be thought of as ratios. They're just ratios of sides of triangles. In particular, a right triangle. We're going to start with right triangle trig. You have 3 sides in any triangle, and ratios usually involve 2 things, so we're going to pick 2 sides at a time. If you like to explore combinatorics, the number of ways that things can happen, how many ways can the first side occur if you're picking sides? I'm going to go with 3, because there are 3 sides to choose from. And then how many sides, or how many ways can the second side occur? 2, because we've used one of them, right? 3 times 2 is 6. So there will be 6 ratios. Let's start with A to B. We have given this a special name because we use these ratios a lot. So for convenience purposes, we give them special names. They could be things like amber, but they're not. They're things like sine, cosine, tangent, cosecant, secant, cotangent. And I'll explain to you later why they're called those things. So A to B could go by 2 different names depending on your vantage point. If your vantage point is from angle A, then this would go by the name tangent. Okay. There is some memorization that has to occur here, because there's nothing in that word tangent that tells you that it's the ratio of the side opposite the angle to the side adjacent the angle. So the tan of an angle, I'll use this Greek letter to represent any angle, is the ratio of the side opposite to that angle to the side adjacent that angle. Question.
So C will always be the hypotenuse?
Usually, by convention, it is the hypotenuse. Next, let's stick with the vantage point of angle A. Another ratio I could have is B to A, right? Just take the reciprocal. This has the name cotangent. And in general, the cotan of an angle, or the cotangent of an angle, is the ratio of the side adjacent that angle to the side opposite that angle. So as you will see, these are just names that we have given ratios, and we ask that you memorize them, because we will be using them a lot. Another ratio we could have here is A to C. Bless you. From angle A's vantage point, that would be called sine. And in general, the sine of an angle is the ratio of the side opposite that angle to the triangle's hypotenuse. Remember, we're working with right triangles here. Later we'll work with non-right triangles, also known as oblique triangles. So with right triangles, you're always going to have a hypotenuse. We have 3 more ratios. We could do B to C. But actually, since I did the reciprocal for the second one, I'll do the reciprocal for this one next. Okay, so C to A. This is cosecant. And in general, cosecant, symbolized CSC, or abbreviated to CSC, is the ratio of the hypotenuse in a right triangle to the side opposite the angle. We have two more. We can do C to B. This is called secant. And this is abbreviated SEC. And it is the ratio of the hypotenuse to the adjacent side. So what I mean by adjacent, if you go back to the diagram, if this is your angle of interest, this would be the adjacent side. It's never the hypotenuse. So if you take the ratio of the hypotenuse to the adjacent side, it goes by the name secant of that angle. And we have one more. Can anyone tell me what it is? Yeah, what's the letter ratio? B to C. It's the one we're missing. That will go by the name of cosine for this triangle. And cosine in general, abbreviated COS, is the ratio of the adjacent side to the hypotenuse. Okay? Now you might be thinking, oh my, this is quite a lot to remember. Let me make it easier for you. You've probably heard of something called SOHCAHTOA. This is what I was taught when I was in high school. This helps to remember the ratios. S stands for sine. O stands for opposite. H stands for hypotenuse. So what that means is that sine equals opposite over hypotenuse. And then cosine, is the ratio of the adjacent side to the hypotenuse. And lastly, TOA, the T is tangent, O is still opposite, A is still adjacent. So tangent is opposite over adjacent. Another natural question is, what about the other three? Well, technically you don't need to have a separate thing for the other three, because the other three are reciprocals of these. So if you just remember who's reciprocal, then you'll be okay. Cosecant is sine's reciprocal. Secant is cosine's reciprocal. And cotangent is tangent's reciprocal. So if you know sine, just flip it and you get cosecant. Therefore, cosecant equals hypotenuse over opposite. I just flipped sine. And secant equals hypotenuse over adjacent. I just flipped cosine's fraction. And lastly, cotan is adjacent over opposite by flipping tan's fraction. I guess you could come up with another mnemonic device here. Cho, sha, cow. Cosecant, hypotenuse opposite. Secant, hypotenuse adjacent. Cotangent, adjacent opposite. But I don't use that personally. Chosha cow. I mean, it's usable. Okay. Any questions regarding the definitions? So this is what we're asking you to remember. What tangent is, what cotangent is, what sine is, what cosecant is, what secant is, what cosine is. And I'll give you some hints along the way, but ultimately it's up to you how you will remember those. Yes? This? This? That's it. They're nothing to be scared of. We're just giving different names to things. Okay? So instead of like Bob and Sally and things like that, they go by the names of cosine, secant. I will tell you why sine is called sine. We'll start there. Because if you do know why, it helps to remember the term. Okay, let's go back in time. 7th to 8th century. India. What language is being spoken? Well, there's multiple ones, but what's a major language that's there? Starts with an S. I'm not sure what they teach you guys these days. It's Sanskrit.
I was gonna say that, but I couldn't think of it. That was like ancient Babylon. Babylon was Sanskrit. Spanish.
So if you look at this mathematical text from 7th to 8th century India, you see a circle. And you see a radius. Anyone know the technical name for this? A chord, very good. And you see right triangles being drawn. So, the people who came up with this said, oh, well, this is a chord, which is Jia. And, no surprise, this is half a chord. Ardha Jha. In yoga, there is a pose called Ardha Chandrasana. It means half moon pose. Ardha is half. The next people who got this knowledge, take a guess, on its way to us or the descendants of many of us. What's that? Before the Spanish? What's in between India and Europe? The Middle East. There we go. Okay. So let's move forward. Approximately 9th century. Middle East. What's the primary language? Arabic. Now, this stuff is getting translated into Arabic. Well, unfortunately, the Arabic translators did not actually translate the word half chord. They transliterated instead. Do you know the difference?
No clue.
They messed up and they did it incorrectly.
Okay. Transliteration means that you take the sound of the word and you put it into your language's symbols.
Oh, okay.
Okay? Make sense? So, Ja got translated into Jiba. Doesn't mean cord in Arabic. I don't know. Next, fast forward, Europe. The Europeans are slow when it comes to discovering math and science. Okay? But they get there eventually. So I'm going to say 13th century. What's the language of scholars? Latin. Okay. Language of scholars in the Islamic Empire was Arabic, so even if you didn't speak Arabic growing up, if you were going to do anything with math or science or with the government, you had to learn Arabic. Okay, it was a huge empire stretching from Spain all the way to like the edge of India. The Latin translators saw this word in Arabic. However, in Arabic, like in Hebrew, you don't have to write the vowels. The vowels. You can just write the consonants. So they saw the J and the B, in Arabic, of course. What letters are these? They're not American. America did not exist.
English.
They're not English. They're not British.
They're
They're before England, before Britain.
Phoenician. No.
I'm going to say no to Phoenician.
Sumerian.
No, these are Latin.
Say that.
Okay. So they took the Arabic and did their best to translate it into Latin. They had to guess as to what Arabic word this was, because they were not provided the vowel sounds. Their best guess was Jaib. Jaib means fold or hollow area. Guess what fold or hollow area is in Latin?
Fold.
It is not.
Whole area.
Close. Even closer.
Cosine.
It's a word that you've probably heard of before. It's a part of your body.
Right.
It sounds like sine.
Yes. Sinus. Very good. They translate it into the word sinus, which means hollow area. Your sinuses are hollow areas.
I mean, yeah.
How does that do math?
And then the English translators eventually, so maybe like 16th century, when people have had enough of Latin, I guess, they convert it to an English word, sign. And if you look up the word sign in like Merriam-Webster's dictionary, you will see that it has, as its roots, sinus, which means fold or hollow area. But that tells you nothing about the geometric reasons for its name, because there was a mistranslation along the way, or somebody just failed to translate along the way. Look back at this diagram, and I'll show you why this relates to what we call sine. Well, if we make this circle simple and give it a radius of 1, And if we call this our angle of interest, theta. Tell me, what is sine of theta? So tell me in general what's sine of theta based on what I taught you before, or what you learned independently.
Opposite over hypotenuse.
Thank you very much. Opposite over hypotenuse. Take a look at this right triangle. What's the opposite? Half chord. What's the hypotenuse? 1. What's half chord over 1 equal to? Half chord. So if you were living in ancient India in like the 700s or 800s, and you were working with trigonometry, you would not be using the word sine, you would be using the word ardhaja, which makes sense, because what we know of as sine is half this chord if the circle has a radius of 1, and we often simplify it to have that. Okay? So that's it. The word that we use really should be based on that, but due to a failure of translation, it didn't. Okay? I'll tell you more stories later. That's one for now. Okay? Now let's put these things to use. We'll use this practice packet. We're given a right triangle, and we're asked to find cosine and cotangent. Again, you need to have the definitions committed to memory. What's important also is what angle they're referring to. It matters a lot. In this case, they're referring to angle B. That's your vantage point. That's where you're looking from. And since I've taught you the knowledge, I think it's appropriate to call on you. Nakia. Let's start with cosine. Cosine is what over what in general?